My name is Nikhil Vaswani, and I'm a junior consultant at Turner & Townsend. And today we are very kindly joined by Hannah Dixon, Director at Progress in Practice. This is a Retrofit Information Support and Expertise event, which is fully funded by the Department of Energy Security and Net Zero, and is delivered by Turner & Townsend. And with that, I will hand over to Hannah for today's peer presentation on an area-based retrofit scheme with Progress in Practice. Thank you, and over to you, Hannah.
So thank you so much, Nicola, and thank you everybody for joining us today. It's a real pleasure to be here talking about this project that we care very passionately about, so it's really nice to be able to share it with everyone. I'll begin just talking you through the agenda, which is essentially to give you a little introduction to myself and our team here at Progress in Practice, and then to talk through the kind of process of the scheme itself, explaining where we started, the design, and then the construction process with some lessons learned as well as at the end of the presentation. So to begin with, you may be wondering who I am and why I'm here. So my name is Hannah Dixon, and I'm an architect, a passive house designer, an AECB certifier, and the founder of Progress in Practice, which is a studio, an architectural studio specialising in low energy, low carbon design, including deep hole dwelling retrofits here in Manchester. I was involved in the Carbon Co-op area-based retrofit scheme from the kind of early days of the design through to the completion of the project on site, along with my colleague Julie, who I'll introduce you to next. So this is our little team. We're made up of chartered architects, retrofit coordinator and Julie, passive house designers, and architectural assistants. So we're a kind of highly skilled team of people who are very, very passionate about reducing both the in-use carbon and embodied carbon of projects that we work on. Julie, I should mention in particular, was involved in the project from the start of it on site. So she actually saw through the whole of the project in terms of the construction phase of the area-based scheme. In terms of Progress in Practice, we were established in 2021. And then since our inception, we've delivered the first 2 AECB carbon light retrofits in Greater Manchester, and the first Passive House Plus project, the first new build Passive House Plus project in the Northwest. And we began work on the Levens Hume scheme in spring 2023. So I'll give you a kind of an introduction to what an area-based scheme is. But to begin with, I think it'd be really useful to kind of set the context for why an area-based scheme is necessary. So the starting point is recognising that we have several million homes to retrofit in the UK. The exact number maybe could be up for discussion. But in terms of decarbonisation and also bringing our homes up to a condition fit for purpose for the 21st century in terms of comfort and health of our buildings, we've got an awful lot of work to do. Currently, we're really only scratching the surface in terms of the delivery of those projects. So the majority of the very large projects in this country are being delivered by social housing providers who are doing maybe hundreds of properties at a time. But in reality, there's roughly 65% of those properties across the UK are owner-occupied homes. So there's a big gap there in terms of the scaling up of retrofit in the UK. So Carbon Co-op's contribution to this was to develop an area-based approach, which was person-centred. So maintained the focus on the end user whilst providing a human-centred approach to retrofit, providing a clear route for retrofit with a focus on quality control. So the theory is that by coming together and combining resources, individual residents in a local area can actually benefit from this the shared resource, the economy of scale, and therefore access a kind of higher level of service and expertise than individual budgets would necessarily allow for. And in terms of this project, Levenshulme was chosen because of Carbon Co-op's existing presence in that area. So they had a kind of established base already. Householders were self-selecting by attending local events held by Carbon Co-op. So public events in the library, leaflet drops, and lots of other kind of small events to draw people in and kind of engage people in the retrofit process. And the role of Carbon Co-op kind of is really key in this particular project, because they acted as this trusted intermediary. And what that meant was that people had access to this kind of really clear route to retrofitting their homes with the quality assurance and the credibility that a trusted partner came with. So for all of the householders, the main point of contact was Carbon Co-op. And because they've done this before and they're very well established in Manchester, they were able to then procure all of the design work and all of the construction work, taking care of all of those maybe slightly unnerving decisions of doing retrofit by yourself. And what that meant for us was that there was an efficiency in terms of dealing directly with Carbon Co-op as opposed to kind of multiple householders and having contracts with each party. And it also meant that both ourselves and also People Powered Retrofit, who did the modelling for the project, and Beetherbox were involved from a very early stage in the project and all contributed and collaborated towards making the kind of scheme as workable as it possibly could be, which is quite a different approach in terms of the construction industry as a whole. Another key aspect of the project was that it was funded through a really innovative process, actually two separate pots of money, basically. So the first is the grants that were available via Carbon Co-op. So they back in the day had a retrofit scheme that was funded via BEIS. That money was loaned out to householders to do their retrofits and was gradually paid back. One of the conditions of the lending for that pot of money was that it then needed to be re-gifted on grant funding for future projects. So this is one of those projects. And then the second one that again really kind of unlocks retrofit for this particular demographic is that the householders had access to 0% interest loans that were attached to the value of the house, meaning that actually they didn't have to pay anything back until the house is sold. And so that clearly kind of removes a fairly chunky barrier for a lot of people. So the way that the project began was through an archetype study, and this was carried out by Urbed. And basically they using Levenshulme as a base, identified, I think it was roughly 6 properties of different footprints, different layouts, different kind of maybe construction build-ups. And so the single archetype that was brought forward for this project was archetype D. And so it was D1 and D2, which was an end terrace and a mid terrace. They all had the same type of construction, more or less the same plans, and they all had gas central heating and radiators, and very little in the way of ventilation. So the idea of creating these archetypes means that when it comes to modelling, it's very simple to take one approach to modelling, adapt it slightly without too much effort, too much complexity, and then be able to extrapolate that along however many houses you have. So it made that process easier for, I'm assuming it did for People Powered Retrofit as they did the modelling. So People Powered Retrofit also carried out the initial reporting on the project. So they did condition surveys, project plans, overheating analysis, and the initial risk register and retrofit assessment that you'd expect to see with a project of this type is more or less consistent with the type of approach you might expect with a PAS 2035 project, but the project is not PAS 2035. It's not required for this project. And PPR, People-Powered Retrofit, also did the modelling, so the energy modelling for the scheme. So as part of the retrofit assessments, they use their software, which is called the Home Retrofit Planner, and I think it's loosely based on SAP, and it's been adapted for them to be able to use it specifically for retrofits and for this kind of scenario. So what they developed from that was an overall target for all of the houses, which was somewhere between 50 and 60 kilowatt hours per metre square per year, which interestingly is roughly in line with, maybe a tiny bit over, the LETI guidance and the AECD carbon light standards. And that's for a complete retrofit of the whole house. For this project, we started from scenario 1, which basically means the first phase of the project. Interestingly, the reason I've got this graph here is that it shows in part the reason for doing retrofit. So the baseline, let's call it it's a row. Baseline row on the graph here shows the modelled energy use to keep the house at a comfortable temperature throughout the year. And then the bills data shows us actually the amount of energy that's being used and how much the house is being heated. So really what it shows us is that the house is not necessarily being kept at a comfortable temperature as it is. And so the modelling shows that if we introduce scenario 1, 2 and 3, whilst the bills might, they may still differ from the model scenario, it may be that actually the bills aren't the main thing that changes in this retrofit, but actually people are able to keep their houses comfortable and warm. So the output of that modelling was that we ended up with scenario 1, which was basically our brief for the project, of external wall insulation to the rear of the houses, top-up loft insulation and a new loft hatch, an airtight loft hatch, high quality double glazed windows to the rear, ventilation, which was mechanical extract ventilation at the time, and then airtightness measures that were kind of associated with that work. So as we're installing windows, making those windows airtight. And that kind of gives you an idea of where we came into the project, and the starting point for us. So whilst Carbon Co-op were this kind of pivotal role in the middle of the project team, and really they were our singular client, it was still really important for us to engage with the householders, because the whole purpose of the project is to give people agency and to kind of bring them on the journey of doing a retrofit to their homes. And the last thing we wanted was for people to not fully understand what was happening and then at the end be shocked by what was going on to their walls or the kind of window choice for some reason. So the way that this was conducted is that we had a series of workshops. This is a picture of me scribbling a thermal bridge to try and explain why we detail external wall insulation in the way that we do. So initial workshops to kind of talk about materials, approach, things like colours. We then had detail workshops where we got into we kind of reviewed the whole of the detailed design pack and made sure that the things that were included in those drawings were really what people understood they were getting, and that included details like an airtight cap flap. So we had at least 2 rather scary looking airtight cap flaps, and then we produced videos. So because obviously we've got a variety of different people in different scenarios, and they weren't always going to be available at the same time. So creating videos that people could consume in their own time, at their own leisure, made things a little bit easier, I think, for both the householders and for us in some regards. And then we produced an illustrated booklet that basically described all of the things that were going to happen on their home make sure that we communicated what it was, not just in terms of the lines on the drawing, but also things like photographs of what the terminal of the ventilation system was going to look like on the wall, so there were as few surprises as possible. And as part of that process, it was necessary to submit a planning application. So we consulted with the local planning authority, and the initial feedback from the planners was that actually the only thing that was going to be acceptable was white render or a brick coloured render. So kind of basically the second row of colours you can see there. This wasn't a popular approach in terms of the group. And so we agreed on a strategy as a whole to pick 2 sets of colour choices for each household. The first one would be the bold choice, the one that they really wanted, that would submit, and then would have a backup, so that if the planners came back and said, absolutely no way you're having blue render, then we'd have something in our pocket to say, well, fine, we'll switch to this. And that way it would just kind of streamline that process and avoid having to then reconsult with the whole of the household team to have to go back to the planners. In the end, what happened was we submitted the first choice colours in the planning application, and it went straight through with no problem, and they look fabulous. And so we ended up with blue, green and black render, or kind of charcoal grey render, orange windows, pink windows and black windows and white windows. So really good, vibrant selection that I think communicates both the kind of the approach in terms of being a people-centered approach, but also ties back to Levenshulme being a really kind of vibrant, diverse, fun community, in terms of the outward appearance. So there's a lot of street art in Levenshulme. There's a lot of community activity, and this just fits in perfectly. So once we had planning, it was important for us to take a really detailed approach to design. And so we basically approached it in the same way that we would with a passive house project. So we made sure that we detailed all of the thermal bridges out. We made sure we had a very good airtightness strategy. And we used products that we knew were going to work from a thermal and an airtightness point of view. So this is just an example of one of those details where the insulation is wrapping around the frame of the window, which isn't a kind of standard detail, to be sure. But it doesn't necessarily cost a huge amount extra. It reinforces the strategy, the thermal strategy, and it de-risks things from a condensation point of view, and makes sure that what we're doing, we're getting the most value from the measures that we are installing. And here's another example of that, which unfortunately has got a bit distorted, but you can see under the sill of the window we've got a bit of compact foam, and again that's just to mitigate that thermal bridging, and it means that we've just got a very high quality install and a high quality finish when it comes to the products themselves. Because you're already paying for the material, you might as well do it in a construct it in a way that works as best as possible. So alongside that, and the thing to kind of mention in terms of detailed design is that because Beaverbox were involved all the way through this process, we were able to have detail workshops with Beaverbox, the builders on the project, and get feedback on details, on costs, on approach to all of these things as we went along, which meant that we knew that by the time the project went to site, that all of these things were more or less buildable. There weren't going to be subsequent discussions and changes once we got to site. And as part of that, we decided to create a specification document that was maybe a little bit different to what we might ordinarily produce. So as opposed to going for a very long, wordy MBS style detailed specification. We wanted to produce something that was as usable and helpful as possible. And so we created a kind of illustrated specification document that showed exactly how things should be installed. So you can see here on the right-hand side, you've got the process of installing a window, which might seem quite straightforward, but we wanted things to be done in a certain sequence and in a certain way to make sure that that airtightness was achievable on site. Equally, having things like you can see the ventilation units here on the bottom, making sure that it was just absolutely clear what that was supposed to look like, where it's supposed to go and how it's supposed to function. So what we ended up with was actually scenario 1A. So throughout the process, there was a lot of consultation and collaboration between Beaverbox, Carbon Carp and ourselves about where we could make efficiencies on the project and try and make things as cost effective as possible, but also where there was potentially additional value to be gained by doing things to a slightly higher spec. So for the external wall insulation to the rear, that pretty much stayed the same as the spec, but there were areas where it kind of increased and decreased. So the average of the whole thing ended up being more or less the same. The top-up insulation to the loft and the new loft hatch was probably a slightly higher spec loft hatch that was taped to all sides and made it completely airtight. We installed windows to the rear. They ended up being triple glazed, as we managed to get a quote for triple glazed windows that was on par with the double glazed windows we had in the project. And actually, a lot of people opted in to doing their front windows as well, which weren't initially included. So it was kind of, there were areas where people could kind of opt out or opt into different options, which again helped with this sense of owning the project. And in terms of, it could add a lot of complexity, but managing it as specific measures meant that we could easily do that on each project, on each household, sorry. The ventilation system is one that we did upgrade. So we had mechanical extract ventilation in the project, and we really felt that we wanted a whole house approach to ventilation, and we wanted to have something that was demand controlled. So as opposed to just having a constant flow of cold air coming into the building, we wanted to make sure that we just brought in the air that we needed to moderate CO2 and humidity in the house, and maintain a good indoor air quality without having this kind of constant flow of cold air. And then air tightness measures as prescribed. So we did all of the air tightness measures around the windows, the loft hatch. So anywhere that work was happening, air tightness was happening. So in the EWI, we were minimizing the number of penetrations going through the wall, and when they went through the wall, they were taped up. And then finally, we have provided additional kind of 3D drawings for the householders so that they know what the next step includes and what they can do to get themselves all the way to that 50 or 60 kilowatt hours per metre square per year. So it takes them the full way through a whole house retrofit at that point. And here's the whole team. So this is just before the project started on site. As you can see, everyone's very happy and excited, despite it being an incredibly hot and sweaty day in a slightly poorly ventilated community centre. But yeah, so this is the start of the project going on site, and it was a really momentous day for everybody, I think. Now I'm going to go on to challenges and lessons learned, because clearly with any project like this, there will be lessons learned. And one of those things that I guess the first thing to touch on, and it seems really obvious, but managing householder expectations is a really, really key part of delivering a project like this. So I guess part of that is being really clear about the process and communicating when when people will hear certain bits of information. So having a plan for updating people on things like timescales and costs can be really useful to help the whole process to feel a bit more transparent. I've been talking a lot about agency and people having decision-making power and being involved in choices. So this will sound like a slight contradiction, but there is a point where choice has the potential to increase the whole project cost. And generally that's why people don't, the big social housing projects don't offer choice, because it would increase the cost of the project. So working out exactly where that sweet spot is, where maybe there's a limited palette, or maybe there's a kind of that is managed in a way that actually it's not completely free rein, but bringing the householders on that journey to agree on that decision and that approach in order to make cost savings for themselves as a group in the long run. And finally, I've kind of, again, this might sound like a contradiction, because we really tried to make sure that we communicated all of these details as clearly as possible. But quite often, as architects and construction industry professionals, we speak jargon occasionally, and we draw drawings and we think, well, we've drawn it on a drawing, so that's communicated now. But that's not how everybody communicates, and in particular technical drawings, not everybody is able to read a technical drawing, or even a kind of a plan sometimes. So it's important to make sure that those decisions and the impact of these measures is really clearly communicated. So, for example, you saw me sketching a thermal bridge detail at the beginning of this slide presentation. That was the detail for running the external wall installation below the DPC, which everybody was on board with. It's a great thing to do to mitigate that thermal bridge. What people hadn't appreciated was the very large trench that was going to be dug around the whole of their external wall in order to install that EWI detail. So having those conversations, hopefully using photographs and things that people can actually visualize, again, it's really important. So another area to kind of consider is the supply chain. So the things that worked really well on this project were the collaboration between Beaverbox, Carbon Carp and ourselves, knowing that we were all really in the project to make it work. So everybody was constantly pulling in the same direction to try and problem solve and to try and make sure that it went as well as it possibly could. What would be great is if everybody involved in the project had the same ethos, had the same stake, had the same inclination. So working a way of bringing suppliers into the delivery team, bringing maybe more of the consultants into the delivery team, so that actually you're able to de-risk the project from that point of view. That would be really positive. Obviously, using trusted partners who you've worked with before and share the ethos and the values of the project would be great. I guess this actually kind of speaks to the relationship with Beaverbox a bit more, in terms of the general approach of the construction industry has always been to do competitive tenders, where clients are maybe pitted against contractors, and that's not always the best way of approaching a project where actually the end goal is to have the shared values. So you're not necessarily going to nurture that collaborative approach by doing these competitive tenders that drive down price and maybe don't foster that approach from the beginning. You're also not likely necessarily to come up with 3 options that fulfill all of that criteria from the beginning. And then the way that the contractor Beaverbox were appointed was through a bespoke partnering contract, which was really very innovative and was part of the success of the project, I think, in terms of the delivery. Because again, it meant that when there were issues on site, which there just always will be, everybody is approaching it from the same point of view and not immediately arguing about costs or blame. And survey early. So again, coming back to this kind of idea that that the archetypes are all the same. So anyone who's worked on a project that has archetyped buildings, you'll know that every single building within that archetype is going to be slightly different in some interesting way. So for example, on this particular example, you can see where we had to take down a shed that was constructed from asbestos. So making sure that those surveys and all of the kind of the potential issues are ironed out really early on in the project is really important. And also allowing a good budget for remedial work. So anticipate that there are going to be problems with the existing construction because this house in particular, these buildings were built, over 100 years ago. And so it's natural that there's going to be some level of remediation required. How far you go with that is another conversation that we could spend another 40 minutes talking about. But yeah, just having an idea of the budget is important. So finally, this is the output. So the project was completed a couple of months ago now, and the householders have been in the whole time and are enjoying their retrofit as we speak. The colours and the kind of specification, I think, is all working really, really well, and we're really pleased with it. And we've had a little bit of feedback from the householders so far that they're benefiting from the insulation and they're benefiting from the ventilation, although it's obviously way too early to start kind of talking about actual measurable outputs. So again, this is an example of one of the airtight cap flaps in the bottom right corner here. But you get a kind of sense of how these are homes that have been shaped by the people who are living within them. They're very much specific to the people who are the householders and their character. So, people-centered retrofit. It gives agency to the to the householder in their retrofit. It enables buying power and therefore provides access to services that are not usually available within that kind of budget. It provides wayfinding through the maze of retrofitting your home. It provides quality assurance, and it also provides this little network of support for the householders, so they can actually they can talk to each other about what's going on, as well as the support of Carbon Co-op themselves. And I think for anyone who's tried to retrofit their own home, they'll be aware of the kind of reams, absolute oodles of information that's out there, and being able to work out who you can trust and who's there to kind of give you genuine advice as opposed to trying to sell you something is quite challenging for people. And I think having that trusted intermediary in the Carbon Co-op was pivotal. It's the next steps. So for the householders, they have next steps mapped out for them. So they've got the details that I mentioned earlier. They've got the option of installing an air source heat pump and removing their gas supply altogether. And for PIP, Carbon Co-op and Beaverbox, we hope that there'll be a phase 2, and we're really looking forward to building on what we've learned and developing the offering to householders. Things that would help would be making these finance arrangements more easily available to more owner-occupiers, so across local authorities, and critically removing that from all retrofits would be really, really useful. Thank you.
Thank you so much for that, Hannah. That was a really inspiring and insightful session on the relevance of area-based schemes.